So welcome to week 5 of 802. When we started off in the very beginning, I told you that the physics of 802 was the foundation for a vast array of technologies. This week we're going to begin our journey from 802 towards those technologies. And over the course of 802 we're going to understand the physics underlying the basic elements of every electric circuit. And the first of those elements that we're going to discuss is the capacitor, and that's what we're going to learn about this week. Later in 802 we'll learn about resistors and we'll learn about inductors, but for this week we're going to be learning about capacitors. But before we can start talking about capacitors, I have to talk about the material out of which a capacitor is made. And we will not be going into great depth on the physics of materials, but I do need to introduce you to the idea that some materials are electric conductors and other materials are electric insulators. You are probably familiar with this division already. What's the basic difference? What is a conductor? Well, an example of a conductor is copper, or aluminum, or gold, or steel, or silver. Conductors are materials in which there are electrons that are free to move. So if I have a conductor here and I apply an electric field pointing this way, the electrons that are free to move in this conductor are going to go this way. Insulators, on the other hand, certainly have lots of electrons inside of them. Every material has lots of electrons inside of them. But in insulators, the electrons cannot move. They're nailed down. They're stuck tightly to an atom, and they can't move. So insulators are examples of materials where if I put some charge here, it stays here. Even if there's an electric field pointing this way, the charge that I put here stays here. So what's an example of an insulator? Well, when I took a plastic rod and rubbed it with fake fur, that was putting charge onto the rod, and the charge stayed where I put it, so that plastic rod is an example of an insulator. Wood is an insulator. Paper is an insulator. This glass that I'm writing on is an insulator. So the materials that we will be talking about in 802 are conductors and insulators. There are actually finer distinctions to be made. For example, we can talk about bad conductors. Yes, there are electrons that move, but there are not very many of them. Those are not typically called bad conductors. They're called semiconductors. And in fact, semiconductors are very important in many technologies. But we will not be doing the physics of semiconductors in 802. For us, it will be sufficient to learn about conductors and insulators. And in fact, in much of what we do this week, we'll be learning about how conductors behave. And actually, if you think about it, everything we've done so far in 802, although I haven't stressed it, has been about insulators in the sense that in 802 so far, we put a plus charge here, and then we put a minus charge there, and then they never moved. That means that plus and that minus charges were sitting in an insulator. We will now be talking about conductors in which electrons can move. And that will be our first step towards understanding how a capacitor works, and the capacitor will be the first building block of modern technology whose physics we will understand in 802.